The domain of a function is the largest set of x values for which f of x is defined. The default domains for 4 of the basic functions are given below. For the absolute value function, y equals the absolute value of x, the domain is all real numbers, since the absolute value of any real number produces another real number. In interval notation, this is written as the interval from negative infinity to infinity. The reciprocal function, y equals 1 over x, has domain all reals except for x equals 0, since division by 0 is undefined. In interval notation, this is written as the interval from negative infinity to 0 union the interval from 0 to infinity. The domain of a radical function depends on whether the index n is even or odd. If n is odd, then y equals the nth root of x has domain all real numbers, or the interval from negative infinity to infinity. If n is even, then y equals the nth root of x has domain from 0 to infinity, including 0. In other words, x greater than or equal to 0. Notice the square bracket to the left of 0 indicates that it is included. The reason that the domain is restricted is that the even root of a negative number is not a real number. Polynomial functions have domain all real numbers, since the sum, difference, and product of two real numbers is always another real number. To summarize, the domain of an algebraic function is all real numbers unless it has an even root of an expression which can be negative, it has a denominator which can be 0, or it is explicitly restricted. An example of a restricted domain would be f of x equals 2x plus 7 for x greater than or equal to negative 1 and less than or equal to 1. Without the restriction, the domain would be all real numbers. But with the restriction, the domain is the closed interval from negative 1 to 1. So if we were to graph this, there would be an end point on both ends of this line, not arrows. This would be where x equals negative 1, and this would be where x equals 1. Find the domain of the function that takes the cube root of g of x equals x squared plus x minus 2. So here we start with the value x, and create g of x, which is x squared plus x minus 2, and then we take the cube root, which gives us the cube root of x squared plus x minus 2. Notice that the domain of g would be all real numbers because x can be any real number when a polynomial function is formed. But now, when we look at the cube root, we have to think about radical functions, since the index is odd, we can take the cube root of any real number. The domain is all reals for cube roots. And so in both cases, the domain is all real numbers. And so the domain for f of x equals the cube root of x squared plus x minus 2 is not at all restricted, is all real numbers from negative infinity to infinity. In the next question, we find the domain of the function that takes the reciprocal of g of x equals the absolute value of x. So in this case, we start with x. It goes to the absolute value of x by the function g, and then it goes to 1 over the absolute value of x by the reciprocal function. Now, because the domain of the absolute value is all real numbers, we start out by x being any real number. But now we know that the absolute value of x cannot equal 0 since the reciprocal function is restricted. So since the absolute value of x cannot equal 0, that implies that x itself cannot be 0, since the only x value whose absolute value is 0 itself. So the domain here for f of x equals 1 over the absolute value of x must not include 0. And so if we looked at a number line, there would be a hole at the value of 0. And so the domain is from negative infinity to 0, union 0 to infinity, and the 0 is not included in either interval. Now we're going to find the domain of the function that takes the reciprocal of g of x equals 3x plus 5. So we start with x, we go to 3x plus 5, and from there we take the reciprocal of 3x plus 5. So g is a polynomial function, so we can have any real number in its domain. But when we take the reciprocal function in this last step, we know that the 3x plus 5 cannot equal 0. And so 3x plus 5 not equal to 0 implies that 3x cannot equal negative 5 and x cannot equal negative 5/3. So our domain would have a hole at negative 5/3. The domain of f of x equals 1 over 3x plus 5 is the interval from negative infinity to negative 5/3 union negative 5/3 infinity. Again, the negative 5/3 is not included in either interval. In example 4, we want the domain of the function that takes the square root of g of x equals 5 minus 3x. So x goes to 5 minus 3x, and now we're taking the square root. And so g, again, is a polynomial function, so any real number. But here, when we take 5 minus 3x to the square root of the same, we know that 5 minus 3x will have to be greater than or equal to 0 because of the domain of the square root function. There, the index by default is 2. So this will give us 5 is greater than or equal to 3x, which in turn gives us 5/3 is greater than or equal to x, which is equivalent to x is less than or equal to 5/3. And so on the number line, this time, we locate 5/3, and x will be all values to the left. So the domain for f of x equals the square root of 5 minus 3x is negative infinity to 5/3, and the 5/3 this time is included. Find the domain of the function that takes the reciprocal of the square root of x. So this time we're going from x to the square root of x to 1 over the square root of x. In the first case, we have a restriction here because the domain for the square root function is x greater than or equal to 0. In the second part, we also have a restriction because in order to take a reciprocal, the square root of x cannot equal 0. So the square root of x not equal to 0 implies x is not equal to 0. So now we have two restrictions. We have, and they both involve 0. We have that x must be greater than or equal to 0, but we also have that x cannot equal 0. So the intersection of these two is that x must be exactly greater than 0. And so in this case, the domain of f of x equals 1 over the square root of x is the interval from 0 to infinity, not including 0.